Shiver me timbers, I never seen a group of sorry-looking cutthroats like you.
Hey everyone, we're going to be doing a few examples from your Exponential and Logarithmic Applications worksheet. So this is one of them. How much money must you deposit in an account that pays 8% annual interest compounded continuously to have a balance of $10,000 after 2 years? We're going to use this formula. It looks like PERT. All right, remember A is the final amount, P is the starting amount, there's our number E, R is our rate in a decimal form, and T is the time. So here we'll have our final amount. Let's see. We have how much money we're wanting to deposit in an account. So we're looking for that initial amount. So we're given the final amount of $10,000. We're looking for P. There's E. Our rate is 8%, so we're going to put that as 0.08. And our time is 2. So we have 10,000 equals P times E to the 0.16. And then to solve for P, we'll divide both sides by E to the 0.16. And that will give us that the amount that we should have initially invested would be $8,521.44. Problem 1, done. Let's move on to the next one. The number of muon decays m was related to the time t in microseconds by the model t equals 15.7 minus 2.48 ln of m. How many decays were recorded when t was equal to 5 microseconds? So it gives us that t is 5. Just plugging that in. And it looks like we're solving for m, the number of muon decays. So first of all, let's see, we can subtract the 15.7 over to the other side. So on one side we'll still have that negative 2.48 ln of m, and then whenever we subtract the 15.7 from the 5, we'll get negative 10.7. At this point we'll want to divide both sides by that negative 2.48, so we'll have the ln of m equals negative 10.7 divided by negative 2.48. We'll do the calculations in just a moment. But I'm going to rewrite this as an exponential expression. And I know some of you have been having trouble with that. Remember that ln means log base e. And that to switch back and forth between the two forms, we have a to the x equals b, and we've got log base a of b equals x. So this first one is exponential form, the second one is logarithmic form, and you can switch them back and forth by just rearranging the values. So the thing that has the exponent is your base, your exponent is on the other side of the log, and then the b is the other thing that's left. So anyways, ln is log base e. So if I want to rewrite this as an exponential expression, log base e, so I'll take my e, raise it to what it's equal to, so this will be the negative, well, the negatives cancel each other out. Okay, so we'll have 10.7 over 2.48, and that will be equal to m. So whenever you plug that into your calculator, e raised to the power of 10.7 divided by 2.48, you'll end up with m is equal to 74.78. So that means we'll have 74.78 muon decays. Let's look at one more. Carbon-14 is a useful dating tool for specimens between 500 and 25,000 years old, such as ancient manuscripts and artifacts. Carbon-14's half-life is 5,730 years. Use this decay formula, which you'll notice this one is a little bit different than the one that you had in your book that looked like this. Remember, we've seen that one. I've even possibly used this one in another video. I can't remember. But this formula will give you the same information as this one that I've got in the word problem. So you can actually use this one. This is easier to use. So that's what we're going to use in this example. So don't panic that it looks different. It still gives you the same information. Okay, so we're going to use this decay formula to determine how many years it will take 1,000 grams of carbon-14 to decay to 10 grams. All right, so we're looking for how long it takes to get to 10 grams from 1,000. So the A was the final amount, I is the initial, then we have 1/2 raised to the power of T, which is what we're solving for, over the half-life, which is 5,730 years. So if I divide both sides by 1,000, so 10 divided by 1,000 is 0.01, and I still have that 1/2 the T over 5,730. So if I want to rewrite this as a log, so that I can solve, a log lets you solve for something that's in the exponent, so I'll take the log, log of, my base is whatever has the exponent, so I've got log base 1/2 of the 0.01 is equal to what was my exponent. So I've got T over 5,730. So to get T by itself, I'll multiply both sides by the 5,730. And I will get that T equals, you can plug this part into the calculator, 38,069.30 years old. And that's the age of, or how long it would take 1,000 grams of carbon-14 to decay to 10 grams. All right, that's it. You'll have a worksheet with plenty of these problems on it for practice. I've already posted it on the video calendar on the website, and I will see you later. Bye.